lab number 3 of the Chem 85 video series. I think that we're Emmy nominated, aren't we?
I think so.
I think there's some Emmys.
We're on the red carpet next week.
I think so, yeah. I'm just trying to decide what I'm going to wear.
I'm wearing my most beautiful dress, and I'm going with Jennifer Aniston. That's all I know.
Oh, good. I think I'll be wearing my lab coat.
My wife will love that.
With my Jeff on it. Hey, today we are doing the third lab. This would be the molar volume of hydrogen gas. So basically what we're taking is we're taking a metal, we're reacting it with a bit of acid, and from that reaction we get a gas, specifically today hydrogen gas. And then what we do with that gas is we're trying to measure the molar volume of the gas, correct?
Exactly right.
All right. So in the lab, I think, just before you get started there, Scott, in the lab, you'll be required to determine the molar volume of hydrogen gas for 3 different reactions, one with magnesium, one with zinc, and one with aluminum. In our lab today, we'll just be doing magnesium, but you'll do pretty well the same thing for all 3 metals. Okay, is there anything else we need to do to set this up, or are we ready to start pouring things?
I think we're pretty close to being, I think we're ready to go.
All right. Okay.
Well, one thing to make note of when you're doing this, obviously, your end result of your molar volume of a hydrogen gas for all 3 of your metals should end up being the same. Now, you're going to have to use a balanced equation to find how many moles of hydrogen gas you should produce, and then compare them to the volume, of course. Now, to get started, we have, I believe it's 24 gauge copper wire in a spool. Okay, now you'll find these spools over on the side counter. Okay, and you want to take off a piece that's about the length of your forearm, give or take. If you have a short forearm, you might want to take a little bit more. If you have a long forearm, you might want to take a little bit less.
I think our video stylist already had some ready for you. I forgot to show you that. Sorry.
No, that's all right. Well, Sherry does good work.
Yeah, she does.
All right, so what you got your piece of copper wire. What you're going to want to do with this copper wire, because we don't want this wire to react with our hydrochloric acid. Okay, our hydrochloric acid will react with copper to produce hydrogen gas as well, and if this reacts with your hydrochloric acid, you will get excess gas in there and it'll throw your molar volume off.
We don't want that.
No, that's bad. Oh. That's bad. So what you're going to do is you're going to take the outside of the copper wire off. So you won't get anything oxidizing, you won't get anything producing gas on the outside of your wire or any impurities on your copper wire. Copper wire takes a lot longer to react than the impurities on the outside of it, so you want to get it so that it's nice and shiny. From there, what you will do next is you will take your piece of magnesium. Okay? Now it's very important that you weigh this piece of magnesium for obvious reasons. Okay, you need to find a number of moles. So make sure you weigh this piece of magnesium. Make sure that if you handle the magnesium, you're handling it with your gloves on, because you don't want the oils from your hands getting into the magnesium, causing a side reaction. Then you're in trouble again.
So how accurate should we be when we weigh that?
You should weigh it to the nearest 100th of a gram.
Okay, 2 decimal places?
2 decimal places.
I'm with you. Okay.
Yeah, definitely 2 decimal places. And you want a piece that is, you know, between 0.03 grams and 0.0345 grams. Somewhere in there. If it's not within that range, you might have some trouble with the actual volume in the udiometer. Okay, but you should just make sure it's between the.
Most of the ones cut up are going to be pretty close, aren't
yeah,
they?
they should be exact actually. They should be in that range, and it'll give you that range. I don't know what I'm talking about there.
That sounds good. No, it's good. They're all cut up, so they shouldn't have to worry too much about that.
They shouldn't have to worry about the mass at all. Now,
yeah.
Oh, sorry. Go ahead.
Well, I was going to say the lab stylist has that already for them.
Yes, exactly. She's got it all cut up. Now, what you want to do with your magnesium is you want to roll it into a coil. Okay, so your magnesium should wind up, and I apologize, I am going to remove my gloves. You shouldn't do this in your lab, but for video purposes, I will remove my gloves. You want it rolled up into a little ball like that. So it's in a little ball. And the reason why is you're going to stick your piece of copper wire through the middle of it. Okay?
Okay.
And then you're going to roll it into a little tiny copper cage that our stylist has gotten together for us already. Okay, that looks something like this one here. Okay, so you have a piece of magnesium inside basically a copper wire ball.
This is sort of fun.
It is, well, chemistry can be fun.
Sort of like kindergarten. I like it. But they don't get to play with hydrochloric acid in kindergarten.
No, not most of the time. My kindergarten they would. So, what you're going to do, you feel sorry for my kid now?
I do, yeah.
What you're going to do is you're going to take your little copper wire ball, you're going to hang it, this is, by the way, is a eudiometer. It's a gas, eudiometer, fancy name for gas tube.
I like that name, eudiometer.
Yeah, I like gas tube.
Okay.
Well, I'll call it gas tube for now, and eudiometer is too hard to say. So what you want to do is you want to hang this wire in, this copper wire, so it's going to have, first of all, make sure your wire ball fits inside the eudiometer, gas tube, okay? And you want to hang the wire so that it fits below the 50 mil mark, okay? It's crucial that you keep it below the scale. And
Crucial to be below the scale, okay?
The reason why is you want to be able to use all of this 50 mil scale. If you can't use the whole 50 mil scale, you might as well have a 30 mil scale, for example.
Yeah, it'd be a pain. You'd be subtracting or something. Yeah.
Yeah.
Okay.
So you don't want to do that. You want to keep it so it's below the 50 mil scale. And before you start adding anything to it, you want to make sure that you can get a cork that'll fit in.
Okay.
Okay. So there you can see my cork fits in. My wire ball is there, okay, with my magnesium inside it. Now what I'm going to do, okay, before I even start pouring things in and getting things ready to go and all that kind of stuff, what I'm going to do is I'm going to make sure that all of this is adjusted to the height that I need. Okay, and with your 1,000 mil graduated cylinder, 1,000 mil graduated cylinders are worth about $1,000. You figure on about $1 a mil.
No way. $1,000 for this?
Okay, maybe not, but you can say they're expensive. Okay.
So treat them right.
Treat them right. Yeah. Be careful with these. Okay. You want to be. The reason why we're going to do this in advance is because we want, when we go and put this all together, we want to be able to do this quickly and painlessly. Okay. So that's a pretty good height. That's a pretty good adjustment. We want our C clamp right at the top here. As you can see with Jeff, okay, he's going to have trouble getting his in there.
I should be higher.
It should be right here. Yeah. And then you're going to lower it down.
Then I can lower it down a bit.
Just like that. Okay, so you want to make sure that this is adjusted properly before you move on to the next step.
That sort of looks cool.
It does look cool. Yeah. In a way, in a chemistry sort of way. Okay, so once you've done that, your next step, you're going to go over, there'll be these jugs on the side. Now, yes, they are filled with distilled water. However, the distilled water is our room temperature water. Now, you can fiddle around with a tap and try and get it to room temperature. It's not as efficient. So what we'll do for this lab and this lab only, we'll use our distilled water for our room temperature water.
Good.
And you are going to
fill it up to about how much?
you want to fill it up. You want to fill up your graduated cylinder to about, I'd say about 600 mils.
600.
Actually,
you're at 700.
Let's fill it all the way to the top, or close to the top.
Okay.
Okay, fill it up to about there. Now that just leaves us enough space so that we can. Holy, that worked out well.
Did work out well.
Leaves us enough space so that we can lower and raise our eudiometer into and out of our graduated cylinder without losing water over the top, and it'll also leave us enough space so that the hydrochloric acid can come through. Okay. From there, for the magnesium step of this experiment, okay, you're going to take your eudiometer. Now, it's important with these things as well that you're careful, because we have ceramic sinks, and ceramic and glass come together and break.
Because these would be probably about $1,000 too.
I actually think these are 1,500. No, they are. Again, this glassware is quite expensive, so just be careful with it. It is graduated. The reason why it's expensive is because it's graduated so well.
That's right.
But what you want to do is you want to place a sponge in the bottom of the sink before you put this in here.
Oh, good idea.
So when you're putting this down on its side, place a sponge in the bottom of the sink. You're going to rest this tip on the sponge, okay, before you pour your hydrochloric acid. Now I'm going to pour this outside of the sink. You should always pour this inside of the sink.
But you think that you're fairly accurate, so you should be good.
I'd stand back. Okay, again, with this is 6 molar hydrochloric acid. Okay, so It's not the nicest stuff in the world. You don't want to drink it. You don't want to get any on your hands. Make sure you're wearing gloves for this step because sometimes this does cause some problems. Now,
And how much are we putting in there?
you're going to put roughly 10 mils in. And I say roughly 10 mils because it actually, the magnesium is the limiting reagent in this experiment, not the hydrochloric acid. So 10 mils of hydrochloric acid is plenty. You will never ever use all that much up in
Sounds
your
good.
reaction. So you're just going to use approximately 10 mils. And I apologize for,
Keep going, keep going. Right about there.
okay.
That's 12.
Okay, that's fine.
All right.
No, so that's fine.
You didn't spill any. You're very good. But we should be doing this in the sink with
You
a
should be doing
sponge.
this in the sink with a sponge, for sure, yeah.
With
And just for safety purposes. Now, what I'm going to do with the rest of the tube, now you'll notice that this hydrochloric acid, well, obviously there's nothing else in there, but it's at the bottom, okay? When you add water to this hydrochloric acid, the hydrochloric acid is obviously more dense than the water. And you will see, when you get this all the way full,
So I get the thing right full.
right,
Okay.
full, yeah. Now you'll notice that as the water comes down, the water will return to the top, and you will see eventually there will be like a flocculent area in there where it's in between your.
A flatulent area?
No, a flocculent area.
Flocculent. Oh, okay.
This might become a flatulent area in a second. Okay, but a flocculent area in the middle here, a little wavy, oily line between your hydrochloric acid and your water. If we were to let it sit for that long, we're not going to let it sit for that long because we're not
And
we're
we
not
want
that
this
patient.
right full.
And we want this right full so it is brimming. And actually, you'll notice there, Jeff, that I've got it full enough that you can actually see the meniscus of the water sitting above the line of
Gotcha.
your tube.
Yeah.
Okay. Now, what you're going to do. Now, it's safe to put this in here. The only reason why it's safe is because, again, we are trusting that the hydrochloric acid is more dense than the water.
So if there was acid at the top, it would start reacting.
It would start reacting right away, but because it's at the bottom, it won't.
Yeah.
Okay, and we're just going to place this in.
Oh, interesting. You didn't
Like
lose
so.
any water.
Yeah, that's kind of. I will in a second, though.
When
Now,
you
the
put the cork in.
reason why is just because of, what's it called?
That thing.
Capillary action.
Sure.
Capillary action, so it'll stay there nicely. Now, when I put the cork in, you are going to lose some water, so make sure you're doing this over the sink. Okay, so the cork goes in, I lose a little bit of water. Again, this is safe, and the only reason why it's safe is because it's water going in there, not acid.
Acid's at the bottom.
Acid's at the bottom.
I can
Okay.
start to see sort of that little level in there.
Yeah, it's
That's
getting
what
there.
I'm talking about.
It'll eventually get there. But
Okay.
you'll notice a huge observation here when I flip it over. Now, what I'm going to do, all in one motion, I'm going to don't be nervous about this. Okay, it's lots of people really freak out when they start to try and flip this over. It takes a long time for the acid to get to the bottom, about 25 seconds. So if you got a lot of time to flip it over. So
So
I'm
you
gonna
should make
flip-
sure your cork is
yeah,
in there
make
good.
sure your cork's in there. I'm going to place it in the water, okay? Forward it into our T-stand. And if you notice, you can see the acid coming down through the water because it's more dense, it's sinking.
Yeah, I see
And
it.
it'll eventually start reacting with the magnesium in the copper wire.
Right, gotcha.
Okay, so it'll come down, and it's kind of, again, it's the hurry up and wait. So you hurry up to get to this point, and then you wait for, it should take about 2 minutes for that to react.
Okay, sort of cool seeing it come down.
The sun or the lights are kind of showing it off very well.
Yeah. I think we have somebody coming in for a lab later. That's what the door is. Okay,
So we're just going to wait for that to react. And
I can start seeing some bubbling happening there.
Yeah, and actually it'll get quite vigorous. Vigorous, good word. Vigorous. It'll
Vigorous
be
is-
vigorous bubbling before the end.
Yeah, better than flatulent.
Better than flatulent.
Yeah, it's going quite good now. All right, so there's lots of bubbling happening. So that bubbling is just
Hydrogen gas.
hydrogen gas.
Hydrogen gas. And the other thing you'll notice, if you take a look down in the bottom of your tube here, as the gas forces the water and hydrochloric acid out of the tube, you'll notice that it's disappearing through the hole made by the by the copper wire as it goes by the tube. Now it's important that we use a 24 gauge wire instead of, say, a 30 or 32 gauge wire, because if the wire was too thin, the force of the gas would force the cork right out through the bottom.
Yeah.
So we're collecting the gas, the acid and water is leaving the eudiometer into this. So at the end, when we're done, we're going to have hydrochloric acid in our water solution here as well. So we have to be careful when we're disposing of that. It can go down the sink, but you want to just watch it and be careful when you're disposing of it.
Look how vigorous it's going now, eh?
Oh, it gets even better.
It gets better than that.
Oh yeah.
That's pretty good. Now, we put in about 12 mils of hydrochloric acid, right?
Mm-hmm.
So, should I make sure that this thing is down, the magnesium is down sort of in that 10-12 mil range, or does it matter that much?
It really doesn't make a difference, because the limiting reagent is the magnesium. So it depends on how much magnesium you have. If you have too much magnesium, then of course you're going to produce too much hydrogen gas, and it'll come below the 50 mark, so you won't be able to get a reading. If you have too little hydrogen gas, it'll come to about the 15 mark, and then you won't be able to get the tube into the water. So you need roughly between 0.3 and 0.34 grams.
Okay. Boy, look at that thing go now.
Yeah, it's kind of neat.
Yeah, I could watch that all day.
It's kind of like a lava lamp from the 70s.
Yeah, it is. We should have some colored lamps or something.
Colored lamps.
Colored lights going on to it. Look at the thing going. We're getting mils of volume just real quick.
Call it the disco lab. Could invite all my tree planting friends here and watch it for hours.
Oh no, here it's slowed way down.
We're slowing right down. So now what's happening now? Obviously, the magnesium has almost completely reacted. What you want to do is you want to just let it set for a while, because obviously we have tons and tons of hydrogen gas that is produced down here that hasn't had a chance to release up to the top yet. So you may notice right now we're at about 29 mils, just about 29 mils of gas. We'll probably get to 30 or 32 before all of these bubbles have dissipated.
So how long should I let it sit for?
I would let it sit for roughly 4 minutes. Okay? So 4 minutes is a good time to let it sit. Now we're not going to let it sit because we're video bound here.
Right.
Okay, so you're going to let it sit for 4 or 5 minutes. When it's sat for 4 or 5 minutes, what you want to do, these are
poker things?
Poker things, yeah. There's a proper name for them. There's a blunt end probe, and this would be a sharp end
probe.
Sure, okay. So this our pointer.
Pointer?
Something like that. Okay, it's basically a curved needle on a stick. Okay, and what you want to do with it is you want to pull this up so you get as close to the surface of the water as possible.
The end of the thing?
The end of the eudiometer. Then you're going to take this and reach in. Okay, and what you want to do is you want to pull the cork out. Now you may notice I did that quite easily. And the reason why is because I've done it about 1,000 times. Okay, this actually does take quite a bit of time. You want to actually push on all the sides so that you don't tip the tube over or cause this to fall on yourself. You want to be really cautious with it. Okay, the other thing you want to get rid of is you want to get rid of your copper wire. So make sure, this is why we took so much copper wire in the beginning.
Yep.
You want to be able to take the copper wire and push it out through the bottom of the tube. The whole time making sure the tube does not come out of the water.
Right.
Okay, once you've done that, you're going to take the tube and you're going to lower it into the water until you get both the level of the hydrogen gas and the level of the water on the outside to be equal, so that the meniscus is on the same levels.
Gotcha.
Now the reason why you want to do that is you want to equalize the pressure on the outside of the tube and on the inside of the tube. It's kind of like an old-fashioned barometer where they used to have mercury in a pool, and in order to find the barometric pressure, they would discuss how many millimeters the mercury would rise. Well, kind of the same thing. Atmospheric pressure is forcing down on the outside of this graduated cylinder, while the hydrogen gas is pushing down on the inside. So by equalizing the levels, we actually equalize the pressure on the inside and the outside, so we can get an actual volume.
Gotcha.
And it looks to me here like we have roughly 28 milliliters of hydrogen gas.
Yep. That sounds good to me.
And from that measurement, what you would do is you'd use your balanced equation, and you take your mass of magnesium, run it through the balanced equation, find out first of all, you'd find out the moles of magnesium, and then find out the moles of hydrogen gas, and then you would take this volume, divide it by the number of moles, and you would have your molar volume of hydrogen gas. And that's the long and short of the whole experiment.
And then we just get to do that with the zinc and the aluminum.
Zinc and aluminum as well. Now, in your lab, hopefully, you'll be able to set up 3 of these at a time. So you want to start with the aluminum. The aluminum takes the longest, so always start with the aluminum. Exactly the same procedure. You want to get your ball of copper wire, get your aluminum in there, get it going right off the bat. Then go back and start with your zinc one. You will have at least 2 of them going at once, so your zinc one can be going at the same time as your aluminum. And then the last one, leave your magnesium for last, because obviously it takes less than 5 minutes.
Yeah, that's a fun one. So that's good, so that's it.
That's it.
We've measured our volume of the hydrogen gas. Now in terms of disposing of this stuff?
In terms of disposing, you should make sure that, first of all, when you wash out your UDometer, so you'll be taking this out, do not take this out and drop it directly onto your bench. Okay, you'll notice that you have to let it drain first, and so many people forget. The easiest way to let it drain is just to tilt it on its side. Okay, you want to tilt it on its side and let it run out. Now these ones here, they'll be in a box at the back, so what you want to do is you want to take a long burette brush, walk over to the sink, put some soap in here, scrub it out, rinse it out with distilled water, and then put it back in the box.
Remember, it's slightly acidic.
Yeah,
right?
It is slightly acidic, so be careful with it. Don't let it drip on your bench, okay? Make sure you do it in a sink.
Yeah.
This one here, obviously, all of our acid from the UDometer has now entered into our graduated cylinder, and you can actually see the difference. You can actually see the acid in there. So what you want to do is you want to take this entire thing can go down the sink, no problems at all. Just pour it down there and you're done.
Okay.
And I think that's about it. All of this stuff, all of your copper can go in the garbage. And please do not throw your corks in the garbage. I think that's all.
That's perfect. Thanks, Scott. So that's molar volume of hydrogen gas. Another fun experiment from Scott. All right. Thanks.